3I, Atlas, the interstellar mystery nearing the Sun, so most of you have probably heard by now. 3I, Atlas, our third confirmed interstellar visitor, has officially passed Mars and is now racing straight toward the Sun at tremendous speed. This is the most intense and unpredictable part of its cosmic journey, the moment where things could either calm down or get very strange. Even now, it's venting streams of water vapor far from the Sun, much farther than any normal comet should. And the gas surrounding it, the coma, is rich in carbon dioxide, giving this wanderer one of the strangest chemical profiles astronomers have ever recorded. Whatever 3I, Atlas is, it definitely wasn't born in our solar system. The discovery. The story of this interstellar visitor began in July 2025, when astronomers in Hawaii's Atlas survey noticed a faint object cutting across the stars, moving far too fast to be bound by the Sun's gravity. Its hyperbolic trajectory made it official. This was an object from beyond our solar system, following in the footsteps of Oumuamua in 2017 and 2I, Borisov in 2019. By early October, it had crossed Mars's orbit. Europe's ExoMars Trace gas orbiter even captured a distant image, a compact glow, no visible tail, just a small bright sphere of light. Unusual, to say the least. Meanwhile, ground-based telescopes and the James Webb Space Telescope joined forces for a deeper look. They found that 3I, ATLAS was ejecting water vapor at about 40 kilograms per second, an astonishing rate for something still nearly 3 times farther from the Sun than Earth. That's like a comet starting its fireworks way before the show even begins. But here's the real twist. The ratio of carbon dioxide to water was completely flipped compared to normal comets. Most comets release mostly water, with a bit of carbon dioxide. This one? The opposite. Think of it as the soda fizz comet, powered by carbon dioxide instead of steam. Polarization readings also revealed dust particles that scatter light in an unusual way, possibly due to microscopic, ultra-fine grains or a bizarre chemistry not seen in local comets. The strange origins. Even older data from NASA's TESS mission showed that 3I, ATLAS was already active 6 astronomical units from the Sun. That's beyond Jupiter, in the cold, dim outskirts where most comets are frozen solid. At that distance, water ice shouldn't even melt. Yet, somehow, this comet was already awake, glowing, venting gas, and acting alive. This tells scientists that 3I, ATLAS must have formed in an extremely cold and distant region of another star system. A place filled with fragile, volatile materials that evaporate at the slightest warmth. In other words, it carries the chemical fingerprints of another world. Its dust composition, too, doesn't match anything we've seen nearby: different minerals, different particle sizes, and maybe even a different structure altogether. Each dust grain is like a tiny time capsule, holding clues about the system it came from. By studying this material, astronomers might actually reconstruct what kind of star and environment created it billions of years ago. Why it's so active, so what's causing this early outburst? One theory says that volatile gases, like carbon dioxide or carbon monoxide, lie just beneath its surface. Even the faint warmth of distant sunlight could make these gases expand, cracking the crust and releasing pressure long before water ice starts to melt. Another theory suggests that its nucleus, the solid core, is extremely porous or fractured, letting sunlight penetrate deep inside and heat it from within. Either way, this is not a typical comet. 3I, Atlas is showing us what foreign solar systems are capable of creating, and it's nothing like what we're used to. The moment of truth, October 29. Now comes the big test. On October 29, 3I, ATLAS will reach perihelion, its closest approach to the Sun, at a blistering 0.53 astronomical units. This is the make or break moment, literally. Astronomers predict three possible outcomes. Massive outburst. It could suddenly erupt, forming a huge, bright tail visible even from Earth. Disintegration. The heat might shatter it into fragments, scattering dust and gas in every direction. Survival. It could simply glide past the Sun, almost unchanged, the most unlikely, but also the most intriguing outcome. Whatever happens, the next few weeks will tell us more about this object than all the months of observation so far. Who's watching? Europe's JUICE spacecraft, now positioned on the far side of the Sun, is in an ideal spot to monitor what happens after perihelion. Because of limited communication, its data will take time to reach Earth, likely by early 2026. Back on Earth, the James Webb Space Telescope, Hubble, and dozens of ground-based observatories will be watching every flicker in brightness and every chemical shift in its coma. If 3I ATLAS survives its solar encounter, it will reappear in early December, passing by Earth at a safe distance of 270 million kilometers. Close enough for clear observation, far enough for comfort. This before and after comparison, pre and post-Sun, will give scientists a one-of-a-kind opportunity to study how solar heat transforms material that formed around a different star entirely. Why it matters with 3I ATLAS joining the tiny club of interstellar visitors, alongside Oumuamua and 2I Borisov. We're starting to glimpse a much larger story. How debris travels between star systems, carrying with it the chemical recipes of alien worlds. Each of these objects is a messenger, a fragment of another solar system, drifting across the galaxy, occasionally passing through ours. They show us how common, or rare, life's ingredients might be elsewhere. They also remind us that the boundary between stars is not as empty as it seems. Every detection improves our early warning systems, helping scientists respond faster the next time an interstellar traveler appears. And someday, we might even send a dedicated spacecraft to chase one down, to sample it directly, and finally touch matter born under another sun. The bigger picture 3I ATLAS stands apart, not just because of its chemistry, but because of its timing. It's like a message in motion, a frozen story from a forgotten star system, passing briefly through our neighborhood before vanishing back into the void. Its strange light, early activity, and unpredictable behavior challenge everything we thought we knew about comets, and remind us that the galaxy is still full of wonders waiting to be understood. When it swings past the Sun on October 29, we won't just be watching another rock in space. We'll be watching a piece of another world, whispering through our solar system for just a moment before it's gone. Because every interstellar visitor, no matter how small or strange, brings with it a single profound truth: that our solar system is not isolated, and that the cosmic story of creation is far bigger than we ever imagined.